Alright, so now we begin our study of trigonometric functions of any angle. We've been focused so far on angles from 0 degrees to 90 degrees, and now we're going to change our focus and it will be 0 degrees to 360 degrees. What I want you to do is get your calculator and try to do these three trigonometric functions with the calculator, and you'll notice something. So pause the video and write down the answers to these three questions. Alright, so now we're back, and I would hope that you have found these numbers. And so what are we noticing that has changed now? And I would think that you can see that so far in our studies of angles from 0 to 90 degrees, we have not had any negative values. Now we will start to see that sometimes the trigonometric function has a negative value and sometimes it has a positive value. And so the study of this is to find out, well, why is this happening, have an understanding of what the difference is and how it affects mathematics when we are working with trigonometric functions. So we have been noticing that an angle is uniquely determined by a point plotted in the Cartesian plane. So let's just draw that Cartesian plane. A little rough sketch here. And make a note that this is our 0, 0. Anything to the right of that has a positive x value, and anything to the left has a negative x value. Anything up has a positive y value, anything down has a negative y value. So when you're plotting points, x, y, you will notice that it's possible to have positive or negative x and positive or negative y. When it comes to the triangles we might form, like this one in particular, the 120 degrees, if I plot my point x, y that creates this 120 degrees, right in here, we're measuring from the positive x-axis all the way past 90 to 120 degrees. So we have, in this case, I have gone to the left for the x value, a negative x. And we've gone up for the y value, so that's positive y. And one thing I want you to remember is that r is always positive. Alright, r is here, the hypotenuse. So, if I try to make these ratios, anything that sits from 90 degrees to 180 degrees is in quadrant 2. We've already looked at quadrant 1. Everything has been positive so far. If I make a ratio of any of the x values in this quadrant with the y values up here, and a positive r value, let's look at that. Well, sine is y over r. In this quadrant, y is always positive, r is always positive. We will receive a positive value. For cosine, we have a negative x value in this quadrant. R is always positive. And, oops, I meant to write, hold on. Let's back up that a minute. X over r. So that means we will get a negative over a positive, and that will result in a negative. And for tangent is y over x. So that means we will have positive over negative, which will result in a negative. And we actually saw that, right? Negative tangent value, negative cosine value, and positive sine value when we were in quadrant 2. Now we could write out the same whole process for angles that lie from 180 to 270. If I look at all of the points that are plotted in quadrant 3, what will they have in common? Think about this one. We have to go to the left for the x value and down for the y value. So when I plot any point in this quadrant, and you're thinking about this now, well, we're going to get a negative x and a negative y. Okay, so let's just clear the screen and we'll look at what that looks like. So now let's look at an angle in quadrant 3 where the x value should be negative and the y value should be negative. R is positive because R is always positive. So I need an angle that lies between 180 and 270. Let's use 200 degrees as our example. And with the calculator, you can punch those into the calculator and find out what the values will be. In fact, we don't even really need to be concerned about the actual value right now. I'm wanting you to focus on the sign of the number. Don't worry about what the number is. In order to create this ratio, we have to put y over r, which will end up as a negative over a positive, which will result in negative. For cosine, x over r, which will be a negative over a positive, which will result in a negative. You do tangent. We end up putting negative y over negative x, which is y over x, which is negative over negative, which is positive. So in this quadrant, the only trig function that is positive is tangent. Okay. As an exercise, I think you should do the same thing for quadrant 4. Pause the video and do this process with it. If you want to use your calculator, that's fine. For a specific angle, you can check that. I'll give you an angle to go with, let's say anything between 270 and 360. 300 degrees. Alright? So pause now. Find out which trigonometric function is positive in quadrant 4 and which ones are negative in quadrant 4. Okay, first thing to consider is in order to plot a point in quadrant 4, we have to have a positive x value, and going down into quadrant 4, the y value will be negative. So, in order to create the sine ratio with y over r, it is going to be negative over positive, negative number. To create the cosine value, it will be x over r, which is positive over positive, positive. And to create the tangent value, y over x, which is negative over positive, which is negative. So we found out only one trigonometric function has positive values in quadrant 4, the cosine. Remember, this one, only the tangent had positive values, and in this one, only sine had positive values. What was it about quadrant 1? who had positive trigonometric function values there, or not who, but which trigonometric functions. Positive x, positive y, r is always positive, everything will turn out positive. All three. Okay? So this leads us to a generalization, something called the cast rule. Alright, and so basically the cast rule tells us where a trigonometric function has positive values. So if I plot my xy axis, cosine is positive in quadrant 4. Let's put a C here. All are positive in quadrant 1. Sine is positive in quadrant 2, and tangent is positive in quadrant 3. If you notice, each trigonometric function is positive in 2 quadrants. So thinking about sine, it is positive here and here. Thinking about cosine, it is positive here and here. And thinking about tangent, it is positive here and here. Alright? So, a number is either positive or negative. If it's 0, it is on the axis itself. But right now, let's think about a number as being positive or negative. So, if sine is not positive, it must be negative. So, if sine is positive in quadrant 1 and 2, then it must be negative in quadrant 3 and 4, and so on. And that's the cast rule.